In this lesson, we will discuss what is the domain model. First and foremost, it's important to recognize that the domain model is a conceptual model. It does not contain a series of well-defined steps or blocks of code that are required to implement an application in this manner. Rather, it gives you a large-scale view of your application and what's called the problem domain. Within the problem domain, you would break down the pieces of information into objects. The objects would fall into several categories. These include entities and value objects. Entities are pieces of information which are of interest to the application, which will ultimately be stored. As an example, we might have customers. Each customer will have a profile. The customers will make purchases. The purchases will involve products. And all of this information will eventually need to be stored. Now, in the process of making a purchase, a temporary object might be created which can store information of interest during the purchase process. So as an example, we might have what's called a value object, which represents the customer's shopping cart. The domain model is also very useful for allowing you to visualize complex relationships. So for example, we might have a one-to-one relationship between customer and profile, a one-to-many between a customer and purchases, and many-to-many between customers and products. The domain model is loosely based upon a series of what are called software design patterns. There's no specific agreement as to which patterns are involved. However, they do tend to fall into four different categories. The first category of patterns would be creational, which includes patterns such as factory, singleton, and builder. Another series of patterns are involved in the structure of the application. So these include things like adapter, decorator, module, and proxy. We also have behavioral patterns which indicate how the software will react in various situations. Such patterns include command, pub/sub, or publish/subscribe, iterator, and strategy. And finally, there are concurrency patterns such as active object, scheduler, lock, and reactor. The domain model revolves around entities. The entities are critical pieces of information which are ultimately stored. The example that we mentioned earlier was customer. Customer will have a series of properties, such as an ID, which is used to uniquely identify one specific customer, name, email, and so forth. The entity will then ultimately be mapped to storage. In this example, we have a customer table with the appropriate fields. Value objects, as mentioned, are only temporary. The example that we mentioned earlier was shopping cart. Shopping cart might contain references to products, quantity, and price. When we say created and then discarded, what this means is that the value object is created during a software request cycle, and then at the end of the cycle, it's simply not stored. It has information that's of interest during the current software cycle. Repositories contain accessor methods that let your application access information in the database without having to be aware of the command set or the specific set of statements for that environment. So as an example, our application may need access to customer entities. The application would call the appropriate find method off of the appropriate repository. You might also create a series of classes referred to as services. Services would contain useful methods which are not specific to storage or not specific to entities or value objects. As an example, we might have a service that shows results in the form of some kind of report. The service may access one or more repositories, and it may access one or more series of entities. In the domain model, there's also the notion of events. Events refer to the timing of the application or the flow of the application. There may be some kind of a management class, such as an event manager. This example is actually drawn from Doctrine. Doctrine has its own event system. In the process of storing an entity into the database, in Doctrine you would call persist to instruct Doctrine that this entity needs to be saved, and then finally flush, which instructs Doctrine to actually do the work. Along the way, there are a series of events which are triggered, which you can then tap into. So for example, you might tap into pre-persist which allows you to inject instructions before the persist operation, or post-persist, which allows you to influence the operations after persist has been called. Likewise, before the actual work is done, there is pre-flush and post-flush. The question that comes to mind is, why do you even need to know anything about the domain model? The answer is that doctrine uses domain model terminology. So if you have a greater understanding of the domain model, you'll be able to more effectively use doctrine. Also, doctrine implements parts of the domain model, although doctrine itself is not the domain model. Finally, do you have to use the domain model if you're building an application using doctrine? The answer to this is no. You can simply use doctrine as is and design your application with whatever methodology suits the purposes of your customers. There's plenty of reference material on the domain model. As a starting point, for example, you might consider the O'Reilly Software Architecture video training series. This series includes the domain model and puts it in the bigger picture of designing software overall.